So we've seen how to isolate host problems by performing successful pings on both the sending and receiving hosts. However, we may still encounter some IP routing problems. These could be because there is a routing problem between the first and the last router between the two hosts. So while troubleshooting, we also need to be able to isolate routing problems that are actually related to the routers. To isolate router-related routing problems, we'll carry out some steps. We need to first check the host's default router connectivity to the destination host. To do this, we can use the extended traceroute command. If the traceroute command is successfully completed, it indicates that there is no routing problem in the forward route or reverse route directions. If the routing problem exists even after the traceroute command is successfully completed, we need to troubleshoot the access control lists, or ACLs, on the interfaces of each router in both directions. To do this, we need to test the forward route when the traceroute command is not completed successfully. To test the forward route, we'll first telnet into the last traced router in the list. Then, find the route of the router that matches the destination IP address used in the traceroute command by using the show IP route IP address command. If a matching route is not found, we need to look for either a routing protocol problem or a static route misconfiguration. The problem may also be that a connected route is missing. If the default route is found to match, we need to confirm that this route is used on the basis of the setting for the IP classless, no IP classless commands. If a matching route is found, we need to ping the next hop IP address in the route. If the matching route is a connected route, we need to ping the true destination IP address. If the ping fails, we ought to check for layer 2 problems or for ACL issues. If a matching route is found and no other problem exists, we should ensure that the route is not inadvertently pointing in the wrong direction. As the third step, we should test the reverse route if a problem is not identified in the forward route test. If the forward route refers to another router as the next hop router, troubleshoot the ACLs on the interfaces of each router from the next hop router in both directions. And if the forward route refers to a connected route, check the IP settings of the destination host. Let's look at an example. In this case, PC1 cannot communicate with PC4, but the hosts can communicate using their default gateways. To isolate the problem, we need to first use the traceroute command. We should use the traceroute 172.16.2.7 command using router A's interface IP address as the source IP address. If the traceroute command is not successfully completed and lists 10.1.13.3 as the last traced IP address, we should start testing the forward route. This tests router C's forward route through 172.16.2.7. If we're still not able to isolate the problem, test the reverse route problem by examining router D's reverse route, which is its route back to the source address 10.1.1.1.